which was to see how good a linear model is for some data. All right, so reasons why this is relevant. There's lots of experiments that get done, whether for school or otherwise, like actual research that maybe like doctors need to do, things like that. I know, I mean, maybe you remember from earlier in the year, but I don't have a degree in teaching. I have a degree in forensic science. So one of the things that we did was collect like DNA, like their own DNA rather, and ran it through some instruments and saw like how good of matches we had to evidence, like, you know, maybe the teacher made some mock evidence and we compared it to see if there was DNA matches and so forth. One of those statistics that we looked at were the R values and other R squared values that you won't need for algebra this year. But one of the things we looked at was our R value. And if it was strong, like above 0.95, we could safely use it to draw conclusions. If it wasn't that strong, if it was anything really below 0.95, then it was unreliable. It was contaminated maybe. It was not a good enough match to say that this matches that evidence and so forth. So when you really like think about it in the grand scheme of things, if you're ever like accused of a crime, I don't know, find yourself in that situation, you'd probably want the data to be really sure that it belongs to you and so forth. Like these have really big real world applications. We, in our data, plotted lines of best fit, plotted our data points on a scatter plot, and use those linear models to answer other things. So this gives you a way to quantify, is my data good data? Is it reliable enough to use the model to make these generalizations about other things? So with that, we went over some facts, which we actually have gone over in here in a separate lesson. So I'm hoping that that was a little easier for you than other things we talked about. But you have to know whether an R value would be considered positive or negative, and strong or weak. Those are the ways that we describe them. Do not confuse R values with residuals. Those are completely different, okay? R values, correlation coefficients, tell you how strong of a relationship there is between some data. We know that if it's closer to -1 or 1, it is stronger. I know that can be confusing for some people. So I included this part about the absolute values, that if the absolute value is closer to 1 than it is to 0, then it's stronger. If it's closer to 0 than it is to 1, then it's weaker. All right. So yeah, keep that in mind. The sign of your R value should match whether the slope is positive or negative for your linear model. That tends to be the easier part. The strong or weak, whether it looks more like a straight line or not, is where students tend to struggle. Okay, so just make sure you know that difference. I know in my 4th hour, we didn't really have time to answer these last questions in the notes. So if you want to take it out, my rest of my class has got to it. But it's also good for everyone's understanding. So see what you can remember from earlier. What does the sign of the correlation coefficient tell you about the data? Just think about it, don't say it yet. So table 6. What does the sign of the correlation coefficient tell you about the data? Like if my R value is positive, what does that mean? So you guys will explain that one. Table 8. If my correlation coefficient, or R value for short, if it's negative, what does that tell me about the data? No, if it's negative, it doesn't tell me that it's positive. Okay, good. Like, in other words, it goes down from left to right if the sign of your R value is negative. It goes down from left to right on your scatter plot if your R value is negative. So then table 6, what about if my R value is positive?
Strength of the linear relationships.
Actually, it doesn't tell you anything about the string. Whether it's positive or negative doesn't tell you anything about the string. If it's negative, it tells you it goes down from left to right. If it's positive, it tells you it come on, guys, connect the dots. I'm gonna say it again. Everyone pay attention. So positive or negative tells me nothing about the string. Positive tells me, well, I'll start with negative since that's the one that was answered right. If it's negative, we know it goes down from left to right. If it's positive, we know it goes. Okay, good. So it goes up from left to right if it is a positive R value. And I say left to right because that's how you read normally. So like if it's positive, it's going up. If it's negative, it's going down. You don't know anything about the string until you really think about the absolute value of it. Is it closer to 1? The absolute value of it, if you think of it that way. Or you could think of it like that little scale that I drew. This one. The closer it is to 0, the weaker. The closer it is to 1 or -1 is stronger. And when we say strong, we mean like linear. So table 4, what does it mean to have a correlation coefficient of 1 or -1? It is strong. And if you don't know what it means to be strong, we mean it's more linear, more of a straight line than not. The points are on your line of estimate. All right, and then you had a couple like examples. It says sketch when it has an R value of 0.9. So it's positive 0.9. We'd expect it to go up. We wouldn't necessarily expect it to be a perfectly straight line because if it was, then we'd have an R value of 1 exactly. So maybe something like that. If I have an R value of -0.5, would we expect it to go up or down? Down because it's negative. Would we expect it to be close to a line of best fit or not? So definitely not all on the line of best fit, but like loosely related to it. You could still tell it's going down from left to right. It's not a no correlation, so it's not 0. It's like right in between. So it is like, I guess, right in the middle. It's hard to say whether it's strong or weak, but I would say it's definitely not strong because then it'd be close to -1 if it was. Okay. So Mondays are short days. Obviously, you only really have 20 minutes now to work on your practice. If you have questions, probably let me know as you go rather than wait because I don't usually have time to check in with you on Mondays. Any questions that don't get answered, you can wait until tomorrow. Miss Medina.